I think yesterday I learned that many people, or some people, don't know who Delfort is. Yeah, so Delfort is a paper group with 6 paper mills. 2 of them are well known, Tervakoski, Opel. Yeah, some people know the mill but don't know the group. And we are specialized in very lightweight paper. So we start at 12 GSM and go up to 74 GSM. As you know, the standard substance in the printing industry is 80 GSM. Marketing once came up to me for a slogan for Delfort. My slogan was, Delfort produces paper below standard substance. The CEO didn't like it. Okay, you are today witnessing, it's like a sneak preview. Yeah, we are working on the high-speed inkjet version of OP Polar Bright. OP Polar Bright is like the standard leaflet paper, I would say worldwide. We also sell it to US and Canada and in Europe. In total, we produce 80,000 tons of leaflet paper. And I want to show on the next slide how much of it has already been printed in high-speed inkjet last year. So last year, already 2,400 tons were printed in high-speed inkjet. Yeah, and really the majority was the standard OP Polar Bright and OP Medical Print that many of you are also printing today in offset. Yeah. So you can really see this paper works. Yeah, it's fine. It's successful in high-speed inkjet. There's some thin jet, 36 or 60 GSM. This is an inkjet treated paper. Yeah, mostly used really for applications with many colors, a lot of printed area, and very low substances, 36 GSM. ThinStar Plus is a coated paper on 60 GSM. Yeah, so also this is successful in high-speed inkjet. And this year, these numbers will go up. Yeah. In publishing, we already are printing a few thousand tons in high-speed inkjet. So this is really the start of high-speed inkjet for us in that market. So of course, for you now, the question is, if the paper works, why are we now working on the high-speed inkjet version? And I want to show this, yeah. So in front you see OPB is the abbreviation of OP Polar Bright. So these are really the advantages you will get, yeah. So higher color gamut, so you have an easier life with customized colors of your pharma companies. Yeah? Some of them are quite difficult in that respect. Optimized ink spread, yeah, this can be important for Japanese letters in font size 3, 4, no? There are many things like that. Then you can use less ink for the same result. Yeah, this doesn't only mean lower costs, but also a better runnability, because you add, I mean, Rob, you also talked about it in your presentation, you just put less water into the paper, and paper wants to expand if you put water into paper, yeah? So this is really a big advantage, also in the converting later on. And you also then have a higher printed opacity. Yeah? Higher print opacity is very important for the pharma companies, because what do the pharma companies do? They take one sheet of your leaflet, put it through a pixel proof or tech for check, and compare it to a PDF. So if you have a bad printed opacity, it's not good for the quality inspection system. So this is also a good benefit, yeah, to increase that. And of course, then the paper will also show you some optimized ink drying. Yeah? Optimized ink drying really means you need less energy for drying. Yeah? And also stresses then the paper less. And then also reduces the link of smearing. Yeah? So these all are the benefits, but the overall target is this. Yeah? So it will give you the opportunity to produce leaflets at lower total costs. Bad news is paper will have its surcharge, but the surcharge will be lower than the cost benefits you will have for the paper. So this is our target. Yeah? Yeah, well, you will see. I will prove. Okay. And this then comes with a higher quality level and also a higher efficiency. So this is the target of the project. First trial production was in April, and on Monday we delivered the first 4 reels to the Pharmadrucker. And doing profiling, this was really now the result, yeah, which you will also see today on the machine. So we see now here on the right, this is the standard paper. And the Pharmadrucker has like set a limit, yeah, for a show-through of 0.16 density. And you can see that you can increase the print density from 0.93 to 1.26, yeah, which is clearly visible. Yeah? I mean, you are the experts. And also the max print density could be increased really high, from 1.18 at 100% to 1.5. Yeah? And the ink saving is at about 10%. And this is so far not yet our end target. Our end target is somewhere at, ink saving should be at 15, 16%. And also the max print density should be somewhere at 1.6, 1.7. Yeah? So this is the end target. But this was now the first try production. And I think we are on a good way. We have an inkjet treated version. The thin jet has the same specs as our OP Medical print. But thin jet is produced in Finland, OP Medical print and OP Papierna. And there we already see an ink saving of 20%. So, yeah. So this is all from my side. Do you have any questions? If you want, I have a lot of printed samples on the show. You can ask me, you can help yourself. It's like a buffet, like yesterday. Just help yourself. And yeah, I wish you a nice rest of the day.